Now I'm going to go over the stoichiometry worksheet. So the stoichiometry worksheet is the same thing, or not the same thing. We're going to use the our skill using the train track method. And another tip to remember is that our mole, when we're converting from an element to a different element, mole is our middle man. And you will see what I mean by that. So starting off with question number 1, calculate the mass of hydrogen formed when 27 grams of aluminum reacts with excess hydrochloric acid according to the balance equation. So the only thing we need is aluminum and hydrogen. So I'm just gonna highlight those two elements, cross those two out, because we only need to focus on those two. So we're given 27 grams of Al. So in order to go to hydrogen, we need to convert aluminum into moles. To do that, we need to get the molecular weight, and the molecular weight of aluminum is 26.78. So there's going to be 26.78 grams of Al and 1 mole of Al. Now, doing that, to go from Al to H2, the way we're going to do that is using the coefficient given in the balance equation. Remember, it has to be balanced. Sometimes your professor will not give you a balanced equation, so double check the equation given is a balanced one. So knowing that, we know there's 2 aluminum going to 3 hydrogen. So that means 2 Al over 3 mole of Al and 3 mole of H2. Okay, perfect. Now, we need to find, since we're calculating the mass, we need to find how many grams there is in H2, in hydrogen. It won't be just 1.01. Here, the mass given in the equation, okay. Here, we're given 2 hydrogen, so we need to times that by 2, which will be 0.016 grams, or no, 2. Knowing that, we know that it will be 1 mole of H2 is equal to 16.16 grams of H2. Knowing that, double check your units by crossing it out and see if you get mass of hydrogen. So cross, 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 giving us grams of hydrogen. So if I times everything out and divide, so times 27 times 3 times 2, divided by everything on the bottom. You will get 3.0246. Here, we're given 2 significant figures, so cut it off at 2. So since we round down, so our answer will be 3.0 grams of hydrogen, H2. And that will be your answer. Question number 2, it says, consider the following reaction. How many moles of oxygen are required to produce 2.33 moles of water? So we only consider oxygen and water. So we can cross out this element. This is not water, this is not water. So the only focus is oxygen and water. So here we're going from product to reactant. So we're kind of working backward, but it's still the same concept. Here we're given that we want to produce 2.33 moles of water. We're given it in moles. So since mole is our middleman in converting element to element, we just look at the coefficient of the balance equation given. So always remember, balance equation. So the coefficient of water is 4 and the coefficient of oxygen is 6. So basically it's saying for every 4 moles of water produced, it requires 6 moles of oxygen to be combined with the other element. So knowing that, we're that. So we're here, we only need moles of oxygen, so we can just stop there. So if we do 2.66 times by 6 divided by 4, our answer should be 3.495. And here we're given a significant figures of 3. So we cut it off right here. We got to round up. So leaving us with 3.50 mole of water. Now we're at our last question. The last question says, according to the following balance reaction, how many moles of KOH will be formed from 5.44 moles of water? So the two elements we're considering, we only need is water and KOH. So let's cross out anything that's in the equation that's not that. And as we can see, the equation is balanced, so we don't have to balance it. Now, let's see. So we're going to reactant to product. So perfect. And we need moles. So we're given, so we need to go moles to moles. 5.44 mole of H2O. And since we're going to convert from element to element, we need to use a coefficient of the balance equation. So basically, it's saying that every 2 moles of water there are, it will form 4 moles of KOH. And if I cross out all the units, I'm given mole of KOH. Now, if I do that, my answer will be 10.88. Here in the problem, we are given 3 significant figures. So cut it off at 3. So we got to round it up. So our answer here will be 10.9 mole of KOH.